Okay, good morning. So it's for some reason everyone's sitting on the right hand side here. So I don't know. I have to kind of balance myself here. Do you want to maybe move in here, guys? Why don't you move in? It's a bit easier. Otherwise, my neck's going to be sore. Just look in one direction. Thank you. And there's a bunch of people who prefer sitting at the back there as well. Come on up, guys. Don't be shy. Okay, let's get started. So, welcome to this tutorial on SD-WAN. For those of you who are not aware, it stands for Software-Defined Wide Area Networks. My name is Paresh Khatri. I work for Nokia. I'm the CTO for the IP Networks Group for Asia Pacific, and I'm based in Brisbane, Australia. So the topic, as I mentioned, is about software-defined WANs or SD-WANs, and you'll see here that I've called it a conceptual overview, and there's a very specific reason I've used that term. It's a conceptual overview because the vast majority, in fact, every single SD-WAN implementation out there is unique in its own way. The implementation itself is proprietary, you could say. So it's a bit hard to talk about SD-WAN without going into the proprietary aspects of SD-WAN, right? Because every company that offers an SD-WAN product does it in their own way. So when I was asked to work on a tutorial like this, I thought, yeah, this is a bit of a challenging exercise. How do I convey the concept of an SD-WAN without actually going into some implementation details? So what I've done is I've taken my understanding of SD-WANs and I've come up with a conceptual view of what an SD-WAN service looks like. So what I might do is everyone's here. I might actually get the clicker if you don't mind. Yeah. Okay, so the agenda for today, I'll start off by looking at enterprise WANs, right? How we've delivered enterprise wide area networks in the past, how it looks now, what are the challenges that we have. And then I'll spend a bit of time talking about what SD-WAN is. This is SD-WAN 101. So this is a very simple tutorial. This is nothing overly complicated, right? But the idea is to give you a sense of what actually makes an SD-WAN service. I'll look at, if time permits, we'll look at cloud SD-WAN. There's a very small section on that. The section that I like to focus on is the use cases. How do you actually use, thank you, Matt. How do you actually use SD-WAN for different scenarios? And I'll also talk very briefly on interoperability of SD-WAN. That's a very small section because it doesn't really exist to any extent. And then we'll look at SASE. So some of you may have heard of SASE as well. So I'll put some context around what SASE is in relation to SD-WAN as well. Okay, so firstly, enterprise WANs. We'll look at the history and evolution of these enterprise WANs, the traditional approach to delivering enterprise wide area networks, some of the challenges, and how we can rethink the concept of what a branch is. Okay, so if you look at this diagram here, what we have is on the left, you've got the traditional idea of what an enterprise wide area network is. This came into being around the 1990s when the idea of data circuits. Should I use that one? Oh, spare one. Okay, excellent. We've got redundancy here today. So we started looking at or operators started to offer wide area network services in the 1990s as businesses were coming online. And the basic premise of this, as you can see here, is we were connecting up these different branch sites, locations of the enterprise, to what was typically a hub site, right? So this is where, I guess there's a bit of a concept of hub and spoke here. So you've got your headquarters where you are potentially hosting some applications. And then you've got all these branch sites connected to it. Typically, what you would have is none of the branch sites would be able to go directly to the internet. The internet connectivity would be through the hub site. So all the traffic would go from the branch sites to the hub site, go through DMZ, the firewall, onto the internet, right? That was a typical architecture. But that's not how branches or enterprises look today. Today, it's a very different ballgame. If you look at this diagram on the right here, you see that the types of connectivity we need and the types of services that we require are actually quite different to the way they used to be. So you certainly got your typical branch sites, but they need connectivity to a lot more than just the hub site. You've got the public cloud, you've got private cloud. You may have a mobile workforce that needs connectivity to your network as well, or at least your customers. If you're an operator, your customers need that kind of a service. We've got IoT endpoints as well. So there's a desire to connect these up. So the whole connectivity environment for the wide area network has completely changed, which means we've got to look at how we build networks to deliver that service. So here, it's a busy sort of chart, but I think it's a very important point that I'm trying to make here is that, the enterprise WAN has evolved over the last 3-4 decades. So the 1990s was, as we said, a very closed network, right? All of the services that were in the network, internet access was just for, nothing important, right? I mean, it was just providing some sort of internet connectivity to your branch sites if required. There was no real e-commerce and so on happening on the internet. Now, we delivered that using what we call private lease lines. They were typically TDM, right? TDM, SDH, Sonnet kind of based services. We use dial-up internet, quite frequently for some of these sites as well. In the 2000s, that became a bit more demanding, right? So virtual compute kind of started entering the mainstream. So a lot of content was starting to get moved onto like private data centers and so on. So this concept of the private lease line evolved, right? So went to firstly frame relay, ATM kind of services, which were once again, they were quite different to SDH services because they were packet based, but they were still similar in the sense that it was a connectivity driven thing. You would set up these connections to deliver services, and the architecture was predominantly hub and spoke, right? Now in the 2000s, to really address the issue of the virtual compute, the fact that all kinds of services were being delivered over IP, right? So voice over IP became very prominent as well. So, at that time, the development of MPLS was in full force as well. So IP VPNs emerged, and that was a great solution. We could now offer that connectivity using IP VPNs over an MPLS infrastructure. And not only could they do IP services, they could do layer 2 services, they could do layer 1 TDM emulation services, and so on. So we've been doing that, right, for the past decade and a half. They've been a premier service that is delivered over MPLS networks. But now, where we stand today, as you saw, the requirements have changed once again. It's a more in-demand kind of a networking paradigm. You need access to your different types of clouds and so on. So this is where SD-WAN has emerged. So SD-WAN, it will not actually, I can't see it completely replacing the MPLS-based services, right? There was obviously a lot of hype when SD-WAN came around, and it's had a fair bit of market success. I just, at least from where I sit, I can't see it, or I don't see it completely replacing MPLS services. They both have a place. But what SD-WAN gives you is the ability to run over different kinds of underlays. And it brings a lot of other interesting capabilities that we did not have with your traditional fixed line enterprise connectivity services. And we'll spend a lot more time looking at that as we go forward. Okay. Now, what are the different elements that make up an enterprise network today? So broadly speaking, a few different islands of connectivity. So firstly, you've got that networking island 1. This is where your IT services reside. And once again, they could be different instantiations of this. This could be on the private cloud. It could be a hosted service by a service provider. It could be a public cloud. It could be some sort of a as a service kind of offering from someone delivered over the internet and so on. That's one. You've got your traditional endpoints, which are your branch sites. You've got your hub sites and so on. That hasn't really changed, but we do add a few more elements to it. We've got IoT endpoints, right, that need to be connected. There could be cameras, sensors, robots, and things that are coming up now. And very importantly, as we saw during the pandemic, the remote access, remote working from home has become an integral part of how we deliver enterprise services. So we have the requirement to deliver a service experience to these remote employees that is identical to that they would receive if they were sitting at a desk at one of the offices. So the consideration here is that we've got to think about all of these when we build a new generation of enterprise connectivity services. So these, a few years ago, there was this interesting survey that was done by IDG Research on some of the pain points that were being experienced by enterprises. And, I think none of this is terribly surprising. So they spoke about the increased complexity and the number of different appliances they had to maintain in their network, right? So if you look at a typical enterprise, there's many different types of devices, firewalls and WAN acceleration engines and so on that are sitting there. And so that leads to a very time-consuming process to do moves, adds, and changes in the network. And what they felt was that as a result of that, there was an overall lack of responsiveness from the network. Not responsiveness in the sense of the service itself, but how fast they could move in terms of new things in the network. And there were some other sort of auxiliary kind of concerns that they had. One was around how do we keep up with auditing and things like applying a consistent policy across all of our branches, for example, right? Now, it could be a security policy, it could be an accounting policy, or so on. And so these were major challenges that we set out to solve with SD-WAN. So just putting that down as a list here in terms of what we want out of a next generation VPN service is things like the ability to do a full range of network and compute services, to provide access to these networking endpoints, to bring automation to networking. We know that a lot of what we do is very manual, right? When you go to when an enterprise comes to a service provider and asks for a new circuit, a new service or something, it takes time. It takes days, if you're lucky, weeks, more likely. We want to be able to speed that up through automation. There's a desire for more visibility of what is happening in the network. That's what enterprises want to know, not just the amount of bandwidth, but what sort of traffic, what application traffic are we carrying over our network. They want more control. Look at the traditional way of delivering wide area network services for enterprises. If you're an operator, you set it up for your customer. The customer cannot directly impact what you're doing in the network. So if they need to change, they have to come to you as an operator. So it's a very cumbersome process, right? So enterprises want a higher degree of control over the network so they can make the changes without having to rely on the operator for everything. So those are some of the challenges that we set out to address. So the branch. So I mentioned the branch, and it's probably sort of dated terminology now. But when we talk about enterprise VPNs or enterprise WANs, we do talk about the branch. Now, the branch is, you've got your fixed elements. So you've got your physical office locations, your shops, and so on, right? So you've still got that buildings. But we add to that your private data centers. So the data center is now an extension of the network. It's not something that's just sitting outside of it. It's got to be thought of as an extension of the network. You've got your retail stores and all that. You might have some of these more sort of itinerant bits of connectivity like kiosks and ATMs or pop-up shops and so on that need connectivity. we've got also this more temporary thing, right? The pop-up stores and the mobile workforce that could be working from anywhere, as we found out during the pandemic. And then you've got the virtual, which is your cloud, right? Public cloud increasingly, and definitely, some of these SaaS kind of services that enterprises today avail themselves of. So all of that forms part of that enterprise connectivity. So the puzzle here is actually, it's quite complicated. There's a lot of things we need to get right in order to provide end-to-end connectivity across all of this. So that's enterprise WANs. So we'll now look at SD-WAN. So this is a very basic, like I said, a very basic introduction to what an SD-WAN looks like. So if someone comes to you and says, hey, what is an SD-WAN? You're able to articulate what that actually means. So we'll look at a definition of SD-WAN. We'll look at SD-WAN standardization at the MEF, right? The Metro Ethernet Forum. I once again compare SD-WAN versus your traditional wide area networks and VPNs from a delivery perspective, how we deliver them. And then I'll look at some of the implementation elements. Like I said, it's hard to talk about SD-WAN without going into details of the implementation. So I've tried to abstract that here. So I'll speak about, in a typical implementation, what you would actually see. I'll look at some of the operational elements of an SD-WAN service. So the definition. So what exactly is an SD-WAN service? Does anyone here know? Can anyone take a guess at what an SD-WAN service is? Right. So that's what it stands for. But what exactly is an SD-WAN service? It's not that easy to define, is it? So you know what? It's like a lot of things. It's there is no single definition for that is adopted by the industry. So when I was building these slides as well, I tried my best to look for a definition that was universal, and I couldn't find it. All right, because it doesn't exist. So the definition of SD-WAN is okay. It's not quite clear. Now, the Metro Ethernet Forum, as I said, has made an effort. So later on, we'll look at the MEF's definition of SD-WAN. It's a bit of a mouthful, right? It's not something you would memorize, but it actually tells you what are the key elements of an SD-WAN, right? So once again, when I was building these slides, I thought, you know what, I don't think I can come up with an SD-WAN definition. If we haven't succeeded in having a uniform, globally accepted definition of SD-WAN, I'm not sure I'll be the one to come up with this. So what I then did was I thought about, what are the attributes of an SD-WAN service? So if you looked at this and you go, hey, it actually ticks these boxes, it must be an SD-WAN service, right? So that's the approach I took. So we'll look at that. Now, before that, just to summarize some of these key elements once again, it's addressing the challenge that is faced by enterprises, right? And this is something that I'm personally very focused on all the time. Technology for the sake of technologies is not very useful. We've got to always start from what the real requirements, what the real operational and service requirements are, and then work backwards, develop technology to actually satisfy those requirements. In fact, so I'll be talking a little bit about that tomorrow as well in one of my sessions. But anyways, coming back to SD-WANs, what we want simplified network management and control. They're two different things. There's a big difference between managing something and controlling something, right? I hope all of you, sort of understand the distinction between the two. Application visibility. We don't really have that with enterprise services. I mean, you could have devices that do DPI and things and achieve some of that. So you can do that with a bolt-on, right? And it's not DPI is not a cheap solution, especially when you start looking at tens of gigabits per second or even hundreds of gigabits per second. DPI doesn't come cheap. But we want that, of course. It doesn't matter if it's not cheaper. We want to achieve that somehow. You want multi-cloud support, so the ability for your enterprises to be able to communicate to any sort of public cloud or private cloud out there. It's important that we have the ability to provide security policies in a very embedded fashion, like an inherent part of the service, so that when we instantiate a service, the security comes with it, right? And you can control what that security policy is. And we want to be able to do things like service chaining. And it's not just actually this, I should update these slides. It's not just a VNF based, but containerized based or any kind of virtualized, cloudified kind of service that is sitting in a data center. We want it to be part of the chain of services that you offer to an enterprise. Traditional enterprise WANs cannot do that. At least they cannot do it as an inherent, innate part of the service. You've got to add something to it to get to that point. But we want that from SD-WAN. So that's one way of looking at the definition. An SD-WAN has some of these capabilities. But it's still a bit general, right? So what I've got here is, as I say, attributes or the fundamental capabilities of what an SD-WAN service is. So instead of having one simple definition, we look at these attributes. It's an SD-WAN service if it's got these attributes. And I'll run through them because this is very key. Now, the first one is that it's an IP-based virtual overlay service. Now, what does that actually mean? In the context of SD-WAN, we speak about an underlay and an overlay. And this is not a new concept. We've been doing it for a long time. The underlay is really your infrastructure layer, right? So this is like your infrastructure layer. The overlay is a service that has been carried over it. So if you think about an MPLS network, the underlay would be the MPLS infrastructure. The overlay would be your IP VPN or VPLS or VPWS services running over it. So that's we make that distinction. So within SD-WAN, what we're actually providing is an IP VPN service, essentially. So it's a service that lets you interconnect up the different locations. They're not just branch sites, as we said, right? There could be cloud endpoints and so on. But we're connecting all of these at an IP layer. So we're delivering IP datagrams between all of these different locations, sites, users, devices, and so on of a subscriber's network. So fundamental to this is still an IP routed service. The second thing is an SD-WAN actually supports a number of different underlays. So it is transport agnostic, as we say. Think about an MPLS network that is delivering IP VPN services. You need an MPLS network. That's your underlay, right? You can't just run it over any network. It has to be an MPLS network. In the case of SD-WAN, it can be really any network, right? Within reason. So it could be the internet. It could be an MPLS network. There's nothing stopping you from delivering SD-WAN services over an MPLS network. There are operators around the world doing it. It could be delivered through any kind of access. It could be delivered through a mobile network. So over an air interface, like 4G access or 5G access. So all of these are supported by SD-WAN, very flexible. So that's good. It supports any topology. So with the appropriate use of policy, you can have a point-to-point construct. You can have hub and spoke. You can have a partial mesh. You can have a full mesh. All of this is very flexibly and easily done with SD-WAN. It also supports this thing called application-aware routing, and this is where we start really getting into the key differentiators between SD-WAN and your traditional VPNs. So what we mean by that is that in a typical SD-WAN service, you are routing on a per flow basis or flow aware basis. So with the use of things like DPI within the SD-WAN endpoints, your endpoint is able to detect the application that a flow belongs to. That's one. So that's important. But not only that, it has the ability to treat different applications in a different manner. So think of an SD-WAN endpoint that is connected through multiple uplinks. One might be an internet uplink. The other one might be over an MPLS network. So for your voice traffic, you might want to send it over your MPLS network. For your browsing traffic, maybe over your internet link. So it can do that because it has an awareness of the application. So it's a very important part of the SD-WAN solution. It can do policy-based packet forwarding. So it's not just destination-based routing, like we said. It can be done on policy. So policy could be application awareness. It could be something else as well. It could be an accounting policy. It could be a security policy. It supports a high availability construct by allowing the enterprise to use multiple different types of underlays all simultaneously. Okay. Now, those were interesting sort of features, but we get to the next part of it, which is around manageability and the application side of it. This is where things get really different with SD-WAN. So SD-WAN provides a complete service automation capability. So what you would have is a centralized controller where you actually dictate the policy for the network. Now, the policies could be simple. It could be like, you've got 6 sites and you want 5 of them to be able to communicate with each other, but the 6th one, you do not want it to communicate with anyone except for the hub site. So that's a policy. That's a connectivity policy. You should be able to do that through a controller. And it gives you that ability to be able to dictate the policy of the controller. And that policy is then pushed down to the rest of the network and implemented. It's got things like automation of CPE. So, ZTP or zero touch provisioning. So the ability to send out a CPE device to an endpoint, a branch site, or someone's home. They plug it in and it pretty much auto configures itself without any intervention from an engineer. The management aspect, as I said, is very important as well. So the service automation gives the control aspect, the management aspect, who actually owns the service, right? And who manages it. So it could be that you outsource. If you're an enterprise, you outsource the service to a service provider looks after it. Or it could be something that's more of a 50-50 kind of thing, where the service provider manages part of the service, but then it actually delegates responsibility for the service to the enterprise. So the enterprise administrator can then go in and make changes to that service. And this is where that element of control comes in, right? I mean, we said that with traditional VPNs, enterprises don't really have that control. Everything has to be done through the service provider. But having this controller means that you can actually delegate that responsibility. And then, it comes to value-added services, right? So most of these SD-WAN implementations out there will support different kinds of value-add services, security services, WAN optimization, firewalls, and many other kind of services. So they all form part of the SD-WAN structure. So does that make sense? Right. So when you're evaluating a service, an SD-WAN service, this is what you get with it, and a lot of this stuff you do not get with traditional VPNs without without some complexity. Okay, so that was my definition of SD-WAN. We'll now look at MEF. So I'm sure most of you are familiar with the MEF. For a long time, they've been developing specifications and implementation agreements for a long time now. Started off with Metro Ethernet, but now they do a lot of other things as well. They've been defining standards around orchestration, even optical standards, and so on. So they got into the mix here with SD-WAN and said, the fact that no one else standardizes any part of SD-WAN, they decided to get into the picture here. So here's the definition that MEF has of the SD-WAN service. So I would like all of you to memorize this. We'll be testing you at the end of the tutorial. No, I'm kidding. Okay, so let me break it down. So MEF says an SD-WAN service is a service that provides a subscriber with a capital S with a virtual overlay, right? So virtual overlay, that's important. So we're using the same physical infrastructure to provision many virtual services that are overlaid on top of it. That enables application aware, right? There's your DPI coming into the definition, policy-driven, policy, and orchestrated connectivity. This is your central controller coming in now between SD-WAN user network interfaces. So this is the MEF doing its MEF thing. Everything in MEF is defined in terms of very specific interfaces. They're very good at that. So a UNI is the point at which the user gets, the enterprise gets connected to the service provider's network, right? So it provides the connectivity between the UNIs that obviously connect to the enterprise. It also provides the logical construct of a layer 3 virtual private network, or routed, a layer 3 virtual private routed network, which conveys IP packets between subscriber sides. Now, MEF3 SD-WAN services can take advantage of multiple underlay connectivity services. So I'll go through this in a bit more detail. Underlay connectivity service is just an underlay, right? So it's a MEF term for it. And it delivers differentiated service capabilities rather than connectivity services based on a single transport facility. So it's a good definition. It's not a bad definition. It covers all the important points of what an SD-WAN service is. Okay. But you can see why this is not like there's a lot to it, right? So it's not easy to describe what SD-WAN is without going into the capabilities of an SD-WAN service, which is why I listed them down in the last two slides there. Okay, so the work that has been produced by the MEF includes one standard that's been released. This was a couple of years ago. It's MEF 70.1. You can download this free of charge from the MEF site. You'll see that this specification defines SD-WAN service attributes and services framework. Very important point, right? The MEF does not specify how an implementation implements an SD-WAN service. So as far as the MEF is concerned, it's a black box. And this is good and bad, right? It's bad because we don't really have any way of building interoperable implementations if nobody specifies the internals of how that black box works. So that's not good. The good side of it is that it works on at least the externally invisible behavior. So the point at which an enterprise connects into an SD-WAN service, that is standardized. So that's useful because you as an operator can now go and build an SD-WAN service with an external interface and a service construct that is aligned to MEF. And that way, there's a degree of, I guess, standardization when it comes to understanding what you will be providing your subscriber. So what it does is it defines, at that point, the UNI, the user network interface, it defines a number of different attributes. So things like the service uptime, what are you providing your customer? The definition of application flows, so that you can obviously provide differentiated service capabilities, policies, the UNI addressing the layer 2 parameters, the VLAN IDs, and so on. So it's not terribly complicated, this bit here, right? But at least they've taken the step of defining this, defining some terminology. And that's also important, because if you're out there selling an SD-WAN service, you've got to talk a language that is understood by other people as well. And having standard terminology actually helps with that. So they've done that. And we'll look at some of these terms. But once again, just to reiterate, it does not dictate how this service is implemented. So this is very different to how, say, the IETF does things, where it actually talks about what's happening in the network. In this case, MEF is talking about how external parties, which is the enterprise, enterprises that are users of the network, interface to the network. Okay, so let me talk you through this here. This is a reference model, or just a diagram, I guess, a reference diagram that helps us to understand the MEF terminology for an SD-WAN service. And I'll go through this reasonably quickly. So what we have here is you've got these 3 blue devices, right? So what these are basically what we call SD-WAN edges. So this could be like a CPE device that sits at the branch side, right? It's got a uni port. So this is a port which connects to the subscriber's network. So it could be the LAN side of the subscriber's network. And then it's got this thing called a SWVC or a SDN virtual connection endpoint. So this is like it's an imaginary point in your CPE device where you're providing policy, right? And so you've got these three devices sitting at three different sites. They are interconnected through a couple of different underlays. So one of them could be the public internet, right? In fact, they both could be the public internet going through two different ISPs. So what we then do is over these IP networks, these underlays, we build tunnels. So you see here that there's a tunnel that connects this device to that device. There's one that connects that to this one, and there's a third one that connects these two devices. So these are what we call tunnel virtual connections. So essentially, what you built here is a set of tunnels that interconnect up all of these sites. It's a very simple concept, right? There's nothing new here. So the idea of the tunnels is nothing new. It can support any kind of IP underlay. Like I said, it could be it could be going through a cellular, a wireless network. It could be public internet. It could be going through an operator's MPLS network as well. The key thing here is that you've interconnected up all of these through tunnels. Okay, so you've got reachability between all of them, and you've got these devices that give you that service capability, the policies, the DPI capability, the ability to do application aware routing, and so on. So this construct is referred to by the MEF as a SD-WAN virtual connection. So just like we have an Ethernet virtual connection, an Ethernet virtual connection is a bit easier to think of, especially if it's a point-to-point connection. This happens to be a multi-point to multi-point logical connection. Once again, I wouldn't worry too much about it. This is just about understanding MEF terminology. Even if you don't really get this, it doesn't matter. Okay. So a bit more terminology, as I mentioned. Okay, that's the SD-WAN edge, the underlying connect. Okay, I've actually spoken about all of that. Now, there's also the concept of internet breakout. So we'll look at that a little bit later. But if you recall, I said that in the traditional VPN, what would happen is you've got all these branch sites connected to a hub site, and internet access, for example, is only through the hub site. So everything's going through that single hub site. Internet breakout is where you can actually get every branch to go straight to the internet, right? If they choose to, without going through the hub site. And that makes sense for reasons of latency and accessing public cloud services and so on. Okay, so the two concepts here that I mentioned, the SD-WAN edge, right? I said that's the box, that's the blue box there. That's the SD-WAN edge. It's the CPE device. So it does a number of things. It performs that. I mean, the basic job of that is to do forwarding, right? To forward traffic between the subscriber's site and the other sites in the SD-WAN network. It performs an application-aware, application-based QoS. It applies security policies as well. It can include some other functions like NAT functions, like firewall capabilities, and so on. In terms of the form factor, right? This could be your traditional CPE device or something that looks like a traditional CPE device. Typically, you'll find that it's running on an x86 kind of processor, right? That's what it's doing. It could also be a virtualized thing that you're running on some sort of COTS hardware. But by and large, most branch sites would typically use a hardware-based platform for this. That box is also called a UCPE, a universal CPE, right? So we'll use the terminology later on as well. Now, as well as that, you've got the SD-WAN controller. So this is something that the MEF does not actually specify, as I said. It specifies a service. It does not say much about the controller. It kind of assumes that there's a controller. It's controlling the service. It's orchestrating it. It's managing it. It's sitting somewhere there. But that's about as far as it goes. But it recognizes that the controller itself has to manage a number of different aspects of the service. It's got to support the configuration of the service, the activation of endpoints, to do things like IP address management, to push down policies, and even do statistics collection for things like for different tunnels to be able to do application aware routing. I've got an example of that use case a little bit later on, which will make it a bit clearer. Okay, any questions so far, guys? Okay, we'll keep going. So SD-WAN versus traditional WANs and VPNs. Let me pull this out. So the key differences here, in SD-WAN, the service instance, right? The definition of the service is in the centralized policy engine, right? So the controller has the definition of service. Now, what do I mean by that? Is anyone here run an MPLS VPN network, or do any of you offer enterprise VPN services to your customers? You do? Another team does it. That's good. Okay. Anybody else? Who else? You do that there as well? Yes. So you know that in order to create a VPN, what do? You go into your provider edge routers, you create a VPN there, right? So for every router on which you have an endpoint that is connected to the VPN, you've got to go in and create the context for the VPN, correct? You've got to go there, attach the CE to it, run some routing protocols, create the MPBGP mesh, and so on. You've got to do all of that to enable the service. So the definition of the VPN service is in the router, and it's done in a distributed fashion. So for every router that is in a part of it has that configuration. Very different in SD-WAN. The definition of that service is in the controller. It's centralized to the controller because there is no such thing as a provider edge, right? All you have is the endpoints, the SD-WAN edge platforms, and the underlay. So that is abstracted out, which is really powerful because that means that you can now control it from a central location. So you change something here, you can push down the change to the rest of the network. Very, very powerful. Okay, so in a traditional VPN, your services are tightly integrated to the network edge, and what I mean by that is the service capabilities are very tied to and dependent on the provider edge platforms that you have in your network. But in an SD-WAN, as I said, there is no provider edge, right? You're using some sort of underlay, and so you're independent of that completely. IPVPNs, okay, it's a slightly older construct. It's been around for a couple of decades now, and it's been rigid. It's very static in terms of how it operates, whereas SD-WAN needs to be very dynamic. Like I said, you have these endpoints that could be temporary. So you want your network to react on demand to changes that are happening in the network. The service configuration in IPVPNs is once again, it's a bit more static, whereas in a SD-WAN, once again, by leveraging the fact that we've got a central controller, you can dictate all of that at the controller and push that down. Now, one thing I wanted to do here, I will not spend too much time on it, is to differentiate SD-WAN and IPVPNs from what we call DIY VPNs, so do-it-yourself kind of VPNs. Now, some enterprises, smaller enterprises have done this for a long time. They get devices that can service VPN endpoints and create these site-to-site kind of IPsec tunnels to create a VPN. Now, we're not talking about these, right? Because these happen without the awareness of you, the operator. You have no idea what some people are doing on. In fact, we probably got no idea what anyone's doing on your network. So what they do is they just get these devices and are able to build some sort of network. We're not talking about that. Okay, I will skip a few of these slides because I'm a bit behind time here, but we've already covered this. Okay, so provisioning SD-WAN services in terms of implementation. So if you look at the left-hand side, right, the two primary types of services that we deliver to our enterprises are your IPVPN services that operate at layer 3. They transport IP datagrams between the different sites. And you've got your carrier Ethernet kind of VPN services, your layer 2 services. A few different types. You have, once again, going back to like a MEF construct, you've got an E-line service, a point-to-point service. You might have a E-LAN service, which is multi-point to multi-point, or you could have a E-tree, which is a point to multi-point kind of service. So many different types of services. They do a really, really good job of interconnecting up the different endpoints, and they will typically reside on a custom-built IP MPLS network. Now, the thing is, these do tend to be more expensive, and there's a reason for it as well, as you know, because operators build the actually underlying network on net. They invest a lot into making this a very highly resilient, available platform with QoS and capacity management to ensure that the enterprise can get the service they actually contracted for. So there's definitely value in that. To do value-added services and more on top of it, we typically have to resort to other appliances, either at the branch side itself or within the service provider's network. So things like QoS and all that. It's kind of bolt on to the service as we said. Now with SD-WAN, it's predominantly layer 3. As we said, that's a definition of it. There are some implementations out there that do layer 2. Like I said, there is no standard definition of SD-WAN. So if someone chooses to do layer 2, they could do layer 2, but it's not common. The value-added services I'm talking about kind of come with SD-WAN. So things like service chaining, link redundancy, application layer QoS, cloud extension as in connectivity to multi-cloud that comes part of it. And it can use an MPLS underlay, or it can use an internet underlay. So now, if you think about this, right, it sounds fantastic. It looks like SD-WAN should just kill it out there. But then there are also downsides, right? If you're going to use the public internet as an underlay, then how do you guarantee performance? Are you, as an enterprise, willing to carry mission critical traffic over an SD-WAN that is running over the public internet? Probably not. So that's why I'm saying that they both have their place. It's not as if one will displace the other. In fact, you can use both in parallel, as we'll see in one of the use cases that we have. You can use MPLS in conjunction with an SD-WAN that is running over the public internet. Okay, so very quickly, some of the implementation elements. So now we start to go into how this thing actually gets implemented without looking at any specific implementation. So static networks is what we have today, right? It's complexity. It's highly customized, right? If any enterprise needs something special, you've got to go in there and come up with a bespoke kind of configuration for it. It is costly for sure, and it's closed. I guess it's a closed kind of system where you have to go through the operator if you're an enterprise. Now, when we go to SD-WAN, we kind of applying the SDN framework, right? So software-defined networking. So SDN brings with it a number of key attributes itself. And it's all about moving from these static networks to a network that is highly automated. So abstraction. So being able to like eliminate or have different tiers of views in the network depending on exactly what you need to know. So your northbound systems don't really need to know all the nitty-gritties of your network, your MTU sizes and this and that and addressing. They probably just need to know what the endpoints are. So abstraction is a way of doing that. Automation, to automate a lot of the stuff that we do by hand. And so we get rid of some of these bespoke configuration challenges. Control, to give the end user more control. In this case, the end user is your customer, your enterprise, but it's also you yourself, to give you more control over the network and provide visibility of what is happening in the network. What sort of traffic are we carrying? And is it actually meeting the SLAs that you have for that service? So I'll go through this very quickly. So implementing SD-WAN, you see that all of these different endpoints of it, of an MPLS, of a SD-WAN service, all of the different types of endpoints, different types of underlays. Some are using dark fiber, some business internet. So this one's riding over some sort of VPN service. There's an internet-based underlay and so on. But all of these are supported. That's the beauty of this, right? You're not tied to any one thing. So the great thing about SD-WAN, you can run over any of these underlays. It's completely abstracted. The second thing is, automation. So if let's say you have some policy here. So in this case, we have a policy that says for this particular branch site, we want our video conferencing to use the encrypted internet link, right? So you look at this office here that has connectivity to the HQ. It's got two links. One's going over an IP VPN network. Which one do you think is going to be more expensive? the IP VPN one. So and a video conferencing traffic you expect will be quite a lot potentially. So what they want to do is, instead of sending the video conferencing traffic over the costly IP VPN link, you want to send it over the internet, but you also want to encrypt it, right? So that this is still your proprietary company data. So you don't want it exposed out there. So you want it encrypted. So you can have a policy that says, do that. If it's video conferencing traffic, send it over the encrypted internet link. But if it's anything else, send it over the MPLS link. How easy would that be to do in a traditional VPN? It's not that easy, right? Yeah. So, but in an SD-WAN, it's actually not that hard at all. Okay. So the control. So this is essentially about giving the customer the enterprise control over moves, adds, and changes. If they want to add a new site, give them the capability to do that. So what they can do is they go into this orchestration platform, the self-service portal or whatever, and they create this new site, new endpoint. Through that, they should be able to organize the delivery of a new CPE device to that location. Once it goes there, everything's set up. It just needs to be connected to the network. It does self-provisioning of that as well, and it's connected to the rest of the network. Once again, that's not something you can easily do. And visibility. So visibility is many things, right? It's not just the applications that are running in the network. It's also about verification. Have I applied my security policies properly? Do all of the sites have the same, access control list, for example? Because I need to do an audit to ensure that it meets my requirements for whatever reason. How can we do that? So you want to have that visibility as well. Okay, so I'll skip this one here as well. Okay, so what does SD-WAN end up looking like? We kind of slowly drilling down. So I'm doing abstraction here as well. So we start over at a very high level, but I'm trying to go down deeper as we go along. So in a typical SD-WAN network, here are the elements you would have. So you've got that policy engine that is sitting in a central location. You've got your different sites, right? They may be hosting some apps in there. These sites could be connected through various different types of underlays, right? So, and each of these could have more than one connection. There could be data centers and clouds or DC environments connected to it as well. So that's at a high level what it kind of looks like. Now, SD-WAN has gone through in its reasonably short life. I think SD-WAN's been around, 8 years, 7, 8 years, something like that. It's relatively short life. It's gone through a few waves of development as well in terms of capabilities. So wave one, I call here from 2014 to 2017. It was very simple. If you recall the hype at the time, it was simply about replacing these costly CPEs with cheaper CPEs. Let me tell you, that never happened. The SD-WAN CPE is not necessarily that much cheaper than a traditional CPE that you use for branch networking, right? But that's how all of these things normally start, with all this hype. And it turns out that what we end up with is completely different to what you think we had. Once again, just a plug for my talk tomorrow on SRv6. Come join me. I'll be talking a little bit about hype there as well. So that was the basic premise, and it was all about branch-to-branch connectivity, right? So we went from your MPLS VPNs to, okay, providing an option here where you could do it through SD-WAN. So not much change there. 2018 to 2020, call it SD-WAN 2.0. So this was a bit different. We started looking at building a network that is a bit more distributed. We brought in this distributed security concept, things like micro segmentation, having policies between different zones. And we also brought in a local breakout. So local breakout as in, if you're using the internet as an underlay anyway, you should be able to allow your branch size to go directly to the internet instead of going through the hub side. So, we kind of built in some capabilities to do that in a secure manner, because that was the thing, right? It's not hard to have breakout to the internet, but can we do it in a secure manner? So that sort of came about a second wave. Now, where we are now is something that we like to call a universal network fabric, right? So fabric is really something that interconnects like all of the different elements that are part of it. And so here we've got all of those different elements that I spoke about earlier. You've got your branch sites, you've got the public internet, you've got the private cloud, you've got public cloud, all of that, right? All of that to be interconnected together. The second thing, which really is now a reality in the post, well, in the COVID. Sure, can we say post COVID? Probably can't, right? Yet. Post-pandemic, okay. Yeah, we're still in it. Okay, so maybe not. I may be a bit premature here, but in this current era that we are, where working from home has become accepted, it's about doing things like what we call a branch of one, right? So an employee working at home to be able to deliver the same service experience. So there's some interesting stuff happening here, right? It may not be feasible for a company with 10,000 employees to ship a $2,000 CPE or whatever it is to each one of these employees. So there are some interesting mechanisms that some SD-WAN vendors are implementing in order to allow a sort of edgeless kind of architecture that still allows these remote workers to interconnect into the rest of the SD-WAN network in a secure manner. And a unified security framework, right? So that it's all endpoints have a consistent policy enforcement of security. And so you're able to do things like local breakout at this point. There'll be more waves of it, I'm sure, by the time I come next year. Okay, so and I'll just build this out actually. Right. Actually, maybe not. I'll step back. Okay. So we now get into the implementation of it. What does it look like? So starting point, we've got these branch sites that we want to hook up together. We've got some other networks that we have to play with. We've got a wide area network. Let's just say it's a private network that a enterprise has. It doesn't have to, but let's just say it's there. There's the public internet. There are some data centers as well that we need to hook up. So in order to deploy that SD-WAN service, we have to have these CPE devices at these branch sites. We call them UCPs, or universal CPEs, typically x86 based kind of platforms that sit there. And then we hook them up to some sort of an underlay. So in this case, two of them are connected up to the internet. One of them is connected up to some other IP WAN. At the data center, you might have some functions like some centralized firewall, some net, some email filtering services, you name it, some sort of services you're delivering from the data center. Now, typically, what an enterprise or a service provider would have is a self-service portal that is used by its enterprise customers. So this self-service portal is essentially used for the enterprise to get in and manage the SD-WAN service. Now, this self-service portal is connected to the orchestrator platform. So like I said, you would have a central orchestrator that is doing policy management, that is doing configuration management. Basically, this is where the brains of the operation is, right? This is where you define the service, what the endpoints are, what the IP addressing plan is, what the accounting policies, what the security policies. And then you have a controller. The controller is tasked with looking after the network side of it, building the tunnels and the routing and so on. Now, this is, like I said, a conceptual overview. When I say an orchestrator, a self-service portal, and a controller, there need not be separate elements. They could all be delivered out of one element. So these are just functional blocks, right? So just keep that in mind. You may often find that the orchestrator and controller are part of the same system. Now, the orchestrator and the controller are talking to the rest of the network, which is really your endpoints, through some sort of a control protocol. Now, this bit is not standardized, as I said, right? There are different ways of doing it. Some implementations use OpenFlow. Some could use something else. You can use a REST API. I mean, you could use whatever you want. But there's communication happening between the controller and the UCP devices. So then they set up these tunnels. So you can see here that there's a tunnel that goes through the firewall. It's a service chain kind of thing. There's one that goes between these CP devices. So that's how you end up with an SD-WAN network, right? These are all the bits of the SD-WAN network. What else was I going to say? Yeah, okay. I'll come back to that. And you got access to the public cloud as well. Okay. So does that make sense in terms of the elements? So you say when you go looking for an SD-WAN solution, what are you looking for? What are the things that are part of it? There'll be the CPE, right? There'll be part of it. The controller will be part of it. Orchestrator, self-service portal may or may not be part of it. Maybe something that you can build yourself using the northbound interface to the orchestrator. So that's really what all the different elements of an SD-WAN service look like. Yes. Sorry, what did you say? The problem? Oh, the concern. Okay. Yeah. 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 Sure. Sure. And this is Richard from. Oh, yeah, okay. Yep. So Richard, yeah, the question is, it's more of a comment. It's not a question. It's a comment that the solutions, all of the SD-WAN solutions tend to be closed proprietary solutions, and yeah, and you know, I've got the same problem with that myself. It's and that's why I said it's very hard to talk about SD-WAN without talking about an implementation, because every implementation is different. So what Richard is saying is, let me elaborate on it. So every vendor that offers SD-WAN service comes with their own CPs. They come with their own controller. So you cannot have a controller from vendor A that works with CPE from vendor B, and vice versa. And that becomes a bit of a challenge. And you know, it's yeah. Look, I'm not quite sure how we're going to go with standardization here. To me, 8 years down the road, we kind of some way into it, right? And maybe that's why we haven't seen that widespread adoption of SD-WAN that the market was sort of hyping about. There's a stark difference between that and how we do things on the internet, where you can get a box from anyone and all of it interoperates, whereas this is a very closed system. So I'm not sure how I can answer that one there, but it is a challenge, and I think I recognize that. Right. Yeah. 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 Sure. You're right. Right. Sure. Yeah. Yeah. But I mean, that's unavoidable, right? You will need internet somehow. Like no matter what you do, you're gonna need internet access. Or, but when you say internet access, do you mean like a wired internet access? Because I mean, it could just be a 4G SIM, right? Yeah, depending on CP. Yeah. Mhm. A wired connection. Okay, so that's the point is not the internet connection. The point is that it's a wired connection that is mandated by the box that you had. Right. Correct. Correct. Yeah. Yeah. But that's unavoidable. I mean, you're going to need some sort of connectivity. But if you could do it through 4G, for example, it makes it a lot easier, right? Because you don't need a wired connection. It's still connect over the internet, and it'll connect to the controller over a secure channel, right? In order to pull that down. Yeah. And then so the next point you raised was, how do you interconnect with, say, the rest of the network that is maybe not SD-WAN? Yeah, like an MPLS network, which is once again going to be the case for a very long time. You will have to, I mean, I can't see too many networks that will be pure SD-WAN. There'll always be a need to integrate with some sort of MPLS, yeah, a hybrid network. That's probably going to be the case forever. So you have to use some sort of border router, a gateway between the two. So I've got an example later on. Hopefully we get to it in 22 minutes left. All right, I'm going to speed up a little bit here, guys. So operation, okay, very quickly. So the operation elements of SD-WAN. Once again, this might be different for some different application for implementations. I've tried to generalize this here. So a traditional operation with well, in a traditional WAN, you cannot allow all traffic unless you explicitly deny it. With most SD-WAN implementations, the intent is that traffic is denied unless you have a policy that explicitly allows it. Okay, so that's one. Traditional WANs, forwarding is a packet by packet approach. You look at every packet and forward it on its merits. Whereas in SD-WAN, we have awareness of flows, right? So we with that application awareness as well, it helps us to categorize packets into flows and treat them as a flow as opposed to independent packets. We have centralized policy-based networking. I've already talked about this, so I will skip that now. We've got application-aware networking. So traditional WANs, you would not look beyond layer 4, whereas with the DPI capabilities that we have in a lot of these CPE devices, you're able to look at the application layer, look into the payload, and work out what sort of an application it is. Okay. You're able to do things like, URL-based web filtering as well with some of the applications on the CP device itself. So it's a very powerful kind of capability. Okay, I will skip this one as well. Okay, maybe I'll just mention it very briefly. So what I mean by cloud SD-WAN is, if you look at the implementation model that I described, we had what are the things we had in the implementation model? We had the CP devices, you had a controller, you had an orchestrator, and possibly a self-service portal, right? Those are things you need. So for certain operators, it may be quite cumbersome and expensive to deploy the orchestrator and controller in their own environments. So there's a few SD-WAN providers out there, or solution providers out there, who actually provide a white label service. So the controller and the orchestrator is sitting in the cloud somewhere. So you as an operator can actually get started with selling SD-WAN services without having invested in any of the infrastructure, because you're getting an SD-WAN implementation as a service. So all you do is you get your customers, ship out CPEs to them, and use the cloud-based solution. So that's what cloud SD-WAN is about. I will not spend too much time on that. Okay, use cases is what I want to talk about very quickly. So the orchestrator, right? Like I said, this is where you define the service. So for example, what we do here is some of the things that we can do, right? Is you go in here firstly, and define a VPN, for example, right? Or a customer service, depends on implementation. And you go, okay, I'm defining a VPN service here, and these are my endpoints, as in my branch sites. And this could be physical location, right? This is my location of this branch site. This is an address. And for each of these branch sites, you design the universal CPE. I say, okay, there's one CPE for this location, that's one for this location, and so on. So you define all of that within the orchestrator itself. And so you're able, once again, depending on the implementation, you're able to get a complete view of the universal CPE on different ports. You can enable different things on different ports and so on. And so essentially, right, putting aside the detail, what you're doing here is you're modeling the service. So this is like, building a Visio diagram of a service on the orchestrator. And then you were able to then push down that service construct to the network, which is all of these UCP devices, right? Now, these UCP devices will come with certain capabilities themselves, right? Like I said, these are x86 kind of implementations. Some of these are based on Linux and so on. So you'll have things like a local DHCP server. They can be running on the device itself. So local DHCP for the LAN side of it, some DNS capabilities, some NAT. You could do some layer 4 firewalls kind of services there, and all of the firewall entries and so on are pushed down by the controller to it. Now, one of the things you raised there, Richard, as well, the process of provisioning a CP device is called bootstrapping, right? So what you do is, what you would do is order a CPE, like a brand new CPE, factory default. It gets sent to the branch site. When it gets to the branch site, it is, depending on implementation, there's different ways of connecting to it. One could be that when you turn it on, it actually exposes a Wi-Fi connection. You join that Wi-Fi network using some credentials that are emailed or sent to you by some sort of out-of-band mechanism, right? So the administrator or an employee at the site, right? It doesn't have to be an administrator. They just get these credentials that allow it to log into the router. And from that point onwards, the CP device will communicate with the controller in a secure manner. And the controller will push down configuration into the CP so that it sets it up. Now, here's the beautiful thing, right? The CPE is controlled and configured completely by the SD-WAN controller. In most SD-WAN implementations out there, there's no such thing as a CLI on this box. You never have to log into this box. Everything is being done through the central controller. So you can see how powerful that is, right? I think it's a very powerful solution if it works well. So it configures that, and then based on the service construct, it will then set up all the tunnels as well. So if you got 9 devices in the network and you add a 10th device, the 10th device will then automatically create all of these tunnels to the other 9 devices, so that you can have this full mesh of connectivity across all of your devices. So I'll skip this, guys, bootstrapping process in a bit more detail. It's in the slides and they're on the website, so feel free to get them. I do want to run through a couple of use cases a few use cases really quickly. Okay, so I'll be quick. So I'll explain the first one, and then I'll explain the differences in the forthcoming ones, so that you can just focus on what's different. So what we have here, right? You've got your SD-WAN control and orchestration. I'll put it in the same sort of box. Doesn't matter, right? It's one of the two doing that function, depending on how we split it. We've got 2 sites here, 2 enterprise sites. You've got a LAN connection hanging off the universal CPE. There's some sort of control channel between the SD-WAN controller, orchestrator, and the UCP. Like you said, this is what we need the internet for, right? You need that somehow. Yeah, it has to communicate somehow, right? So it could be, but the underlay. Ideally, it should support both wireless and wired connections as well. So you have that. That is not standardized, right? Like I said, so it depends on your implementation. So you've got the same thing happening here as well. And then you've got this underlay, right? Now it could be the internet, or it could be some other IP network. And here I've got some notes on what that is, right? Now, what we do is this is a very simple network. So when you've set this up, what will happen is that this UCP or this SD-WAN controller will instruct this UCP to set up a tunnel to the other UCP, right? In this case, the tunnel is encrypting encapsulating your IP traffic over VXLAN, which is then being sent over IPsec. Now, typically, that's what you want, of course. If you're going to send traffic over the public internet, you want it encrypted. So this is one way of doing it. There could be other encapsulations, right? Depending on implementation. So in this network here, it's very simple. We're using the internet or any other IP network, really, as the underlay. You use IPsec security. Both of the branches are single-homed. And the other great thing here is that the underlay does not need to be owned by the service provider. It could be anyone's underlay. So you could have a service provider that is providing the SD-WAN service, but a completely different service provider over whose network we are riding, right, for the data plane itself. So it's more of a disaggregated kind of service delivery model. Now, what I've shown here is multiple enterprises. So it's not just one enterprise. Now, you can create a VPN for another enterprise as well, right, over the same physical infrastructure. So all we've added here is another set of, another couple of branches for enterprise number 2. So it's a very simple use case. Now, for the sake of redundancy, what some enterprises will do is use 2 underlays. So, you know, if there's something wrong with this ISP, for example, if something goes down, then you still want connectivity. So the option is to use another ISP to provide the second link. So the difference here is that this guy's got 2 links. They're both internet underlays, and so does this enterprise here. So that if there's a failure, catastrophic failure in one of them, the service continues. Okay, hybrid. So there's different types of hybrid, right? So this one here is where we're actually, okay, this one's the same as the first example, but as well as that, we have got a link to an MPLS network. So here, we are using the MPLS network as an underlay for the SD-WAN service. We're not actually, okay, we have a MPLS service there for sure, but the VPN is being provided over that MPLS service. So in fact, this is slightly more complicated. This is an overlay over an overlay over an underlay, if you think about it. But if you don't want to think about it now, that's okay. Slide 59, keep thinking over the next few days. Why would you do this? It's because maybe you've got some high priority, some mission critical traffic that you don't want to mess around with. You want it being sent over a MPLS network. Okay. This is the other case. Now, this is a different case. This is another type of hybrid, where you've got a hybrid network where, well, actually, maybe not. Maybe okay, just ignore that. I'll come to that in the next slide. I'm running a bit ahead of myself. Okay, so this network here, forget about this one for now. Sorry, forget about that one and look at this one. This is it's very similar to what we had before, right? An SD-WAN network. Now we come back to this. Your primary network is an MPLS network. So what you have here is an MPLS VPN service. So you've got 3 branches connected to the MPLS WAN service. So this operator tends to prefer MPLS for whatever reason. But then they've got a need to extend their service to a certain part of the country or a town or an area where there is no MPLS reach for whatever reason. They go, what do I do now? So the option is, you know what, let's use an SD-WAN service because the internet is everywhere. So they introduce a new branch here, branch 4, that is performing a SD-WAN function, right? So the branch connects to the public internet using the same sort of, encrypted overlay tunnel. But then in the MPLS network, it terminates on a border router. So that tunnel is not terminating on another CP device. It's terminating on a gateway or a border router, right? So that border router terminates that encrypted traffic, and it then connects into the MPLS network. So the way to think about this is on this border router, it has 2 personalities. On the left side it's an MPLS CPE, right? A CE device, right? A customer edge device. On the right-hand side, it's a UCP, and it's connecting up the two. So that's how you would typically do that sort of hybrid. Now, this is what we call off-net extension, right? Because you're just providing a certain number of sites access to the MPLS network when you don't have that MPLS access. But this could be, if you extend this, it could be a situation where you do have, part of your network running MPLS, part of your network running on SD-WAN, which will once again be a common case. And so the concept is also very similar. You have a border router that sits between the SD-WAN side of it and the MPLS side of it, and allows all of these devices to communicate with each other. So if you think about MPLS, right, you see that when this is acting like a CE, it's like to this network, it looks like one branch. This whole thing looks like one branch, right? So it'll be able to route everything through that branch. And then once it gets to the border router, it's got better understanding of where to route the specific traffic for the different endpoints. Yes. As an endpoint? Yeah, exactly. That's what I was saying. So here on the left-hand side, it acts as a universal CPE. On the right-hand side, it acts like a customized, like a CE. Yeah. Okay, and you can do things like service chaining, right? So you can send it through a data center where it goes to a firewall and some other services on the way to the internet. Now, local internet breakout, like I said, it's previously you used to go through a hub site, but if you're using the internet as an underlay, you may as well use that to break out your internet traffic. So what would happen is for your corporate traffic or traffic that is destined to your corporate subnets, it actually gets encrypted and sent over this overlay. And there could be many other sites. And anything else gets routed to the internet without encryption. And you would obviously have your firewall policies in there to control the security of that traffic. Public cloud access is pretty much the same as internet access. Now, application-aware routing. I think I mentioned it before. I'll go through this really quickly, right? So let's just say you've got, actually, I've got another. Yeah, okay. This example has two UCPs. There is a internet underlay. There's an MPLS underlay. Now, what you want to do is you want to send your video conferencing traffic to branch 2 over this link here. Now, for whatever reason, this video conferencing link is very important to you. I mean, obviously, you gotta control things like latency and so on. So you set a policy that says, I want my video conferencing traffic to go over the link with the lowest latency. So what would happen in this situation when you enable application-aware routing is that the controller would instruct these CP devices to measure the latency between the two parts or on both the parts. So it's continuously doing this performance measurement of latency. And depending on which one is the lowest latency, it'll send the traffic down that path. If that changes for whatever reason, then it'll send it to the other path. So this is very powerful, right? You can really reuse this capability. Also, we tend to sort of not emphasize the fact that this is giving you active load sharing here. Whereas a lot of MPLS kind of VPNs is active standby. If one link fails, then the other one kicks in. Whereas here, you're getting active, you're getting use of both of the links at the same time. Okay, I'm going to skip this one here. Just about the end of time. Okay, interoperability. I think we already talked about it, right? So this was the shortest section in this presentation because it doesn't exist. But I'll talk about it anyway very quickly. So SD-WAN, they're mainly closed systems. UCP hardware, you could say, okay, you know what? You can get x86 boxes. So there's some degree of interoperability, but this is not an SD-WAN function, right? Yeah, so yes, short section. Okay, so I didn't think I'd get here given the time, but I think we've done all right. So let me summarize. we very quickly looked at enterprise WANs, right? How we deliver enterprise WANs. We've been doing it for the last 30 years. We looked at some of the challenges of those, but we also looked at the key requirements that enterprises have when it comes to enterprise networks today, right? And then we looked at building a definition of SD-WAN. So I went through the different attributes. I still think that's a good way of doing it. Look at the different attributes of a SD-WAN service. We looked at the elements that make up an SD-WAN service from a conceptual perspective. And then I went through a bunch of use cases that shows how you can interconnect different sites. We looked at some of these hybrid scenarios as well. So I hope that was useful. If anyone has any questions, I'm more than happy to attempt to answer them. Well, looks like all of you are ready for lunch, so we need to make an announcement.
In regards to lunch, it's not at the tent down there because there's a function there tonight. So I think we've got to go to the party tent where all the music's from, over in the back corner over there. I don't know if there's going to be music, but that's where you got to walk through. How to get there, I'm not too sure, but follow someone.
The only positive bit of information there, or the confirmed bit of information, is that it's not there. All right, cool. Thanks, Warren. All right, guys. Thank you very much, and yeah, appreciate you attending the presentation today.